Hello, Mr. Stoller here. So today we're looking at a quadratic function and where you need to sketch. So here we're asked to, to sketch and also determine the turning point. So now for you to sketch, what you need first is intercepts. So make sure that you get the intercepts first. Then the second thing is the turning point in this kind of a function. So you need a turning point. Okay, then you also need to know the shape. So in terms of the shape, you know that if a, like for here, it's in the form of ax squared plus q. So if the here is negative, so once it's negative, we know that if a is negative, is less than 0, it means that our shape is said. Then if AE is above 0, it means it's actually smiling. Okay, so here you can see with what you call it's curving up. Then from there now we need to get the intercepts. Let's start to get the intercepts here. For y-intercept, we already know that if in the q is actually the y-intercept. So in this case here, our 4 is the y-intercept. So here, one talking of the y-intercept, let's see. Okay, y-intercept is actually y equal to 4. So in this case, it's going to be 0 and 4. So here, that's where it's going to cut on the y-axis. Then x-intercept, okay, intercepts is actually, you make y equal to 0. Okay, you're making y equal to 0. Now, if you make y equal to 0, in this case, it's going to be 0 is equal to negative x squared plus 4. Then we take the x squared there, it's going to be positive. Then going to be x squared is going to be equal to 4. Then from there, we root both sides. So if you root both sides, you're going to get x going to be equal to plus minus what you call root of 4, which is equal to negative 2 or negative or positive 2. Okay, so once we have a root sign, what happens is that when you have a root sign, you must not forget to put the plus minus here, because it always have 2 values. Okay, now let's sketch our we need to find the turning point. So to find the turning point is, we get the x by saying x is equal to minus b over 2a. Okay, now to get the turning point here, what is our b? We don't have b is 0, and so it means that the turning point is 0. Okay, so it's on the on the y-axis. That's what it means. It's going to be 0 over negative 2. So in this case, it's equal to 0. So we know that it's cutting on the y-axis. Okay, now, so in your grade, in the grade 10, you know that your graph does not shift horizontal. It does not shift horizontally, it only shifts vertically. That's why we have the q there. It's either you take it up or you shift it down. Okay, so now let's do the sketch here. So we have got the x, we have got the y. Okay, now we know that it's where is the 4. The 4 is actually our turning point. And where is it facing? It's facing down. Our graph is facing down. Why is it facing down? Because of the negative that we're having. Okay, so we have the negative there, and here is going like this. Okay, so here we know that this is going to be our negative 2. There's a 2. Then here it's a 4. Okay, so once we have this, we can now say, okay, our turning point is 0 and 4. Then our intercepts, we have our intercepts here. Our intercepts, we've already specified them here, negative 2 and 0 on the x-intercepts, then also 2 and 0. Okay, that's what we have. So now let's talk of domain and range. Domain. So domain for quadratic functions, you know that x is element of real numbers. Okay, so it's active from negative infinity to positive infinity. Then let's talk of the range. Now, with the range, you know that we're talking of y, where it's occupying y. So we're looking at the y values. So here, these are y values in terms of the range. Now, with the y values, here we can see that it's from 4 going down. So it's a y is less than 4. So y is less than 4. That's our range. Okay. Y is less than 4 because it's going to go down. We don't have any value occupied by y, occupied by the graph above 4. So we have that. Now let's also talk of, does it have a maximum or a minimum turning point? The turning point in this case here is a maximum turning point. So here is a maximum turning point. So I'm just going to use TP is the maximum turning point. Then does it have an asymptote or no? We don't have asymptotes here. So no asymptotes. So in this case here, there are no asymptotes. So just like the linear, there is no asymptotes. So you don't need to worry about what is it? The asymptote in terms of what is it in terms of the X. Then what else can we talk of? Increasing and decreasing. So let's talk of increasing. Okay, when we're talking of increasing, we are saying where the gradient is positive, that's where it's increasing, and when it's decreasing is when the graph, or what we call the graph, the gradient is actually negative. So where is it positive? Where is the gradient positive? Our gradient is positive here because of the shape is going uphill. Then here the gradient is equal to 0. Then here the gradient is negative. So here gradient is negative. So where is it increasing? It's increasing from x less than, it's x less than what is it? Less than 0. Okay, so x less than 0. That's where it's increasing. What about decreasing? It's x greater than 0. Where x is equal to 0, the gradient is equal to 0. So here it's not increasing or decreasing, but it's changing from increasing to decreasing. Okay, so I think that's all what you need to that you need to know. Here we know, let's just come back here, just indicate that here it's a maximum turning point. This one, it will be having a minimum. Okay, so thank you so much. All the best.